Okay, welcome back to Life Science. Today I'm going to be covering section 10.2, part 2, looking at plant responses, specifically chemical stimuli. Not a very long lecture today. I'm just going to talk about 4 chemicals that plants do have a response to, and talk about their responsibilities or how plants respond to them. So, chemical stimuli. So remember, a stimuli is something in an organism's environment that causes a response. And so great examples of chemical stimuli in plants are plant hormones, substances that act as chemical messengers within the plants. We have hormones. We have growth hormones, hormones that tell us to grow, hormones that tell us, when to make insulin or to break down sugars and all of that. So, it's really important that our hormones are balanced. Well, with plant hormones, there are 4 chemical messengers I'm going to talk about. So the first one is auxins, which was mentioned in our video yesterday, if YouTube allowed me to show it. And auxins, their main job is to increase plant growth as well as phototropism. And how auxins work is they tend to concentrate on the dark side of the stem. So let's just say that the sun is straight on. This is my control. So the plant just grows upright. If I cap it, it's still just going to be upright. But if the sun moves, if I change the direction of my sunlight, auxin moves away from the light. And it causes a response in these cells to elongate, to stretch. So auxin causes cells to elongate. And when these cells elongate and these cells stay the same size, now you see that this half bends toward the light. So that's what auxins do. They move away from light, They cause cells to elongate so that way the plant bends toward the light. So there's that phototropism part. And then also auxins do increase plant growth, as mentioned in the movie, or that short YouTube clip yesterday about tropisms. The second plant hormone I'd like to talk about is ethylene. Ethylene's main job is to stimulate ripening of fruits especially, or maybe the dropping of leaves. And maybe you've noticed this with bananas. Every week my husband buys a bunch of bananas. He has a banana every single day for lunch, And he always buys them super, super green, and then over the course of the week, they end up like this. However, sometimes he doesn't always finish his bananas from the previous week, So my husband didn't know this, but, bananas, when they ripen, they release ethylene gas, and they can cause other fruits to ripen. So if you have a banana that's looking kind of spotty over, like this, and you place it to buy other fruit, it might cause that other fruit to ripen. And as a result, maybe, you don't eat it fast enough and you might have some food waste. So my husband, whenever he buys a bunch of, whenever he buys a bunch of bananas from Willie's, he always makes sure he takes the old banana and places it far away, pretty much the opposite side of the kitchen for me to eat the next day on my toast. Peanut butter. Delicious. All right, the last 2 are very similar to each other. They both increase cell division and cell elongation, and those are the gibberellins and the cytokinins. Basically, they stimulate mitosis, and when you have more mitosis, then you have more cells, and when you have more cells, the plant grows. So it just kind of makes sense. All right. That does it for section 10.2, looking at plant responses with environmental stimuli versus chemical stimuli. You have a 10.2 worksheet that is due tomorrow. Tomorrow's lecture, I'm going to focus in on plant reproduction and their life cycles. And then on Thursday, just talk about the parts of a flower. And then on Friday, you're going to have an open note, open book test on chapter 10. So we're kind of wrapping up chapter 10. After chapter 10, I believe we jump right into animals. And so the rest of the year, we'll spend our time focusing in on animals. So, all right, until next time.